Hello everyone, welcome back to Intermediate Python. This is now class 6 out of 7. Last week we left off with using some built-in modules. Last time we used random. Today I will go over another very useful module that you can use. In addition, I will also be going over recursion. I will also be going over other Python IDEs to use to download PyCharm. In case you didn't know, PyCharm is a Python IDE, and I will explain that later. As you may know, there is no computer science without maths involved. Today we will be going over the maths module. And remember, make sure to run the import math first before running any module-specific functions, math module. Now, Python by itself, without importing any modules, does not really have a lot of tools and flexibility for mathematical calculations, etc. But the math module grants you access to a vast range of constants, tools, and operations. Now, there may be a bunch of math-related terms that you don't know. Just make sure you remember how to access these things, and the goal is to really learn how to use these tools rather than like what these tools are about. Constants are some like values that you can use. For example, as you can see here, it's okay if you like don't know what all these mean. Just know that they are there. Like a famous constant that you might know is pi, 3.1415. But other than that, there's a bunch of other constants such as Euler's number, now infinity, and not a number. Now, to refer to these constants, you can do mass.constantName, which, let's say I want to refer to pi in my code, I would use mass.pi. There's also some numeric functions that you can use. The following functions will save you a lot of time when it comes to doing math with Python. A lot of these functions would otherwise have to be programmed by yourself, if not for the math module. It's really helpful. And to use these functions, you can do mass.functionName with the specified parameters. Now, first off, we have the ceiling and floor functions. These functions ceil gives the ceiling value, which returns the smallest integer value that is greater than m, and floor, the floor value returns the greatest integer value smaller than m. And after each time when I go over module-related function, I will explain it on the next slide. As you can see here, if num equals 3.14 and I run mass.ceil with num, it returns 4 because the smallest integer that's greater than 3.14 is 4. So if I run mass.floor with num, it will return 3 because the largest integer smaller than 3.14 is 3. Next off, we also have factorial, and this is a really useful function. It returns the factorial of num. Now, once again, you don't necessarily have to like completely understand what these terms mean, but you should like know how they work at the very least. Num must be an integer, and from you've taken any like math classes, you may recognize the factorial of m in math as n with an exclamation mark. So you can do that in Python as well. Now, if num equals 5 and num2 equals 7, the factorial of num, which factorial of 5, will be 120 because 5 times 4 times 3 times 2 times 1 is 120. Just giving you an overview of how the factorial works. In addition, if you were to run mass.factorial on 7, it'll give you 5040, right? Because 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 5040, right? 5040. Now you can also use Python to find the GCD of two numbers. GCD was the parameters num1, num2, or two parameters. It will find the greatest common factor of these two numbers. For example, mass.gcd 120 and 180 would return 60. Greatest common divisor of 120 and 180 is 60. You can also use the LCM function, which finds the least common multiple of these two numbers. If I were to run mass.lcm 120 and 180, it will give me 360. This is the absolute value function associated with the math module. It's called fabs. It's a refresher on what absolute value is. It's basically distance from a number to 0. All right. You might think that this is a typo because you might know that Python has a built-in function does the same thing called abs. All right, stands for absolute value. It's actually not a typo. Anyways, if you abs is, as I said, it's basically the same thing as a built-in function called abs. They both give you the absolute value of a number, and the difference is that fabs works on real numbers only, while abs can work on both real and imaginary numbers. In Python, again, if you don't know what imaginary numbers are, it's completely fine. It's a learning process. But in Python, in case you do know, in Python you can represent imaginary numbers with J or uppercase J rather than conventional I in math. Now, fabs would be used when you want to make sure that your function won't return an imaginary number. Python's built-in function, abs, is actually more versatile than the math module function. But like using whichever one is up to you, and most of the time it doesn't really matter. As you can see here, just I imported the math module, of course. I printed negative 10.213, and of course that will give me 10.213, all right, positive. I would do to do the same thing with the math module function fabs, it would give me the same thing because they both perform absolute value. If I were to run abs on a complex number, for example, 2j, which is 2i, it would actually give me 2. Now, if I were to run fabs on this complex number, since fabs cannot accept real numbers as a parameter, it will return an error. Next up, we have x, exponent of a number. The exponent function is used to find the value of any power num of e. That's a typo right there. It's supposed to be of. This is only really used to find powers of the constant e, which is around 2.71. For example, print mass dot exponent of 5 would return the value of e raised to the fifth power. And remember, e is the name of a constant. Remember to not use this function for normal exponential calculations because you will be using it wrong if you do that. The correct way to find the exponential value of two numbers in Python is to use the PAL function. This function will help you find the value of x raised to the y power. And if I were to print math PAL 3, 4, it will return the value of 3 raised to the fourth power. To represent this in Python, use these two star symbols. Of course, this will give me 81. Remember, PAL will give you the value of num1 raised to the num2's power. Right? Let me just give you another example. If I were to print math.pal 2, 2, it will give me 4 because 2 raised to the second power is 4. For those of you who are like more advanced in math, you can also do logarithms in Python. It returns the logarithmic value of num2 and base num1. Now there's also math.log2 and math.log10 functions for log bases 2 and 10 specifically. You can use this. I will try to keep this at a similar level for everyone. Also very important, the square root function. Of course, it will obviously be the square root of n. Number num and num must be a positive real number. As you may know, the square root of 16 in math is 4. To do math dot square root 16, give you 4.0. Yeah, if it's like let's say a natural number, it will actually end in 0.0. Just I know I've gone over a bunch of functions already, a bunch of constants. This may be a little confusing, but surprise, there's actually a lot more functions than the ones that I already demonstrated, such as trigonometric functions, etc. The ones that I went over so far are really the ones that I feel like are the most relevant to what we're doing. But you can feel free to explore them on your own if you're interested. Actually, not be going over these because of time constraints. Here we have a practice problem. You don't really have to use any of the slightly more advanced math functions. For this one, our first practice is, as you may know, in math, the hypotenuse of a right triangle C can be solved for using the equation a squared plus b squared equals c squared, where a and b are the lengths of legs of a triangle. This is known as the Pythagorean theorem. You might know this. What you want to do is write a Python function that takes the lengths of the triangle legs a and b and prints the lengths of c. Now remember, in Python, an exponent a raised to the b's power can be written as a with two star symbols, asterisk b. Now if you don't know like what hypotenuse right triangle is, just focus on equation a squared plus b squared equals c squared for now. Turn that into a Python function. Now, if you need any more clarification explaining or just hints, you can message me in the chat. Good luck. Now, I will be posting all of the math functions from the math module that we went over in the chat. How I did it, so I just imported the math module, made it a simple function, parameters a and b, and just printed a math dot square root a squared plus b squared. Find this part to variable if you want. The variable worked just fine. We'll go over the next part of today's lesson, which is recursion. Recursion in a function is when you use a function like this. So in recursion, you would see this inside exact same function. Always recursion is really useful when you have a large problem and need it to like broken down into smaller pieces, like when you have a way to do that. A really good example of recursion is the factorial function from earlier that I mentioned, factorial function from the math module. Now, imagine if that did not exist and you have to write it on your own, you have to do recursion. You may know factorial function is defined, factorial of n is defined as n times n minus 1 times n minus 2 all the way to times 1, all right, with 0 factorial being 1. So the recursion function would look something like this. See, it has two branches, f of x equals 1, x equals 0. If x equals 0, then f of x equals 1. And if x is greater than 0, then this right here. Remember, like 5 factorial equals 5 times 4 times 3 times 2 times 1. All right. For example, 12 factorial would be 12 times 11 times 10 times 9 all the way to times 1. All right. So I should clear up any questions about factorials. The way factorial works isn't really the main focus here, but it's rather how to implement it in Python. As you can see here, I wrote like code for a factorial right here. Using this, we have a function defined named factorial. A factorial with parameter x. Now, if x equals 0, now remember there's a double equal sign when in if statements. If x equals 0, return 1. Otherwise, you return x times factorial of x minus 1. As you can see here, factorial function is being used within itself. Every time you run this, x would decrease. Now, of course, we are in the last few classes, so we are getting into some pretty advanced material and deeper depths. Use return here. You see, I don't actually have print here. We used return because return allows the program to receive the value of x much better. If print was used, the function would not work. Now, unlike print, you can't really see the results of a function if it uses return. To do that, you would have to assign a variable to the usage of the function right here. Use print on that to see the result. If I were to do factorial 5, result equals factorial 5, and I print result, it would give me 120. One of the most important parts of writing the recursion function is having this right here, so you know what to include in your if-else statement. Usually you see a bunch of if statements within a factorial. I mean, within any recursion problems really. Another example of recursion is the Fibonacci sequence. All right. If you don't know what a Fibonacci sequence is, which is completely fine, the sequence starts with 0 and 1, and every next number is equal to the sum of the previous two numbers. Just move this down. So we start with 0 and 1, and what's the sum of 0 and 1? It's 1. What's the sum of 1 and 1? It's 2. Sum of 1 and 2 is 3. Sum of 2 and 3 is 5, etc. So the nth Fibonacci number can be given by this function right here. If n is smaller than 1, then f of n. F of n just refers to the function is equals to n, and otherwise is equal to f of n minus 1 plus f of n minus 2. You can really see the similarities between this and this. They both have their like branches, alright, of where to go if for a certain value of variable. Based on what we have here, similar recursion function using this. I will actually provide you with the code for the factorial function so that you can kind of see how it works, and then you can develop your function for Fibonacci sequence by basing it off this code right here. Now you can base your code off of this. Actually, also provide you with this, as you can call, map of what to do, the factorial function, so that you can really kind of see the similarities. In case you didn't know, to write smaller than and greater, smaller than and equal to sign, you write it as smaller than sign followed by equal sign. Same thing for the greater than or equal to sign. You write it by using a greater than symbol and then an equal sign. If you actually use this symbol in Python, it would not work. So you would have to write it as this. Problem may be a little challenging. This problem may seem a little difficult at first, but once you really see the similarities between this and the factorial recursion problem, it becomes easy. The key thing is to know what to do when the recursion part is applied. Basically, when you would use function that you created within your function. Right? There's no two separate functions for this. It's just one function that uses itself. One more thing, when you're writing code, just make sure you write the if parts as like a proper if statement. Just copy like word for word this part, it will not work. So you have to write it as a proper if statement. Another extremely important part is to use return instead of print. Since we are like nearing time, I will briefly go over IDEs like in preparation for next week's class, which I know most of you or perhaps all of you are using Python IDLE right now. It's an IDE, so congratulations. An IDE is an integrated development environment. Python IDLE is a default IDE for Python that comes with every download. You can download other IDEs are much better code debugging, editing code, executing code. Most popular IDEs is PyCharm. You might know PyCharm. It says developed by JetBrains, and I use PyCharm for almost all my projects. And I use a community edition, which is free. Here are just a few features of PyCharm. With PyCharm, one of the greatest benefits is that you can code like this. To get PyCharm installed on your device, you can just go to this link right here. I will provide you with the link in my next email. Have a good weekend, everyone, and thanks for coming.